Hey guys, here we'll look back into the concepts we have learned in our previous episodes and try to find some unique insights by solving a relatively easy problem. The purpose of this episode is to create a base for the upcoming two episodes where we will solve a couple of challenging problems. So we have two numbers a and b, and we want to find out the bit positions where values are different between a and b. Also, we want to count the number of differences. First, let's understand a hypothetical cell phone system design. We have a cell phone brand having two models of the same phone, one of which has two cameras and the other version has four cameras. Now, internally, the camera module in each phone knows which of the cameras exist in that phone. We will name this variable the camera bit mask. So, for the Pro version, the bit mask will have 4 set bits where each set bit corresponds to a particular camera in the phone. In the non-Pro version, the camera module has the camera bit mask as 1010, which means this phone only has 2 cameras. Now, suppose in the non-Pro version, the Android application erroneously sends a request to the camera module to turn on 4 cameras, which is conveyed by a variable in the message request called camera on request mask. Of course, this would lead to an error in the camera module as the phone only has 2 cameras. So the camera module sends feedback to the Android application that hey, in your request message, you have asked me to turn on 4 cameras, of which 2 cameras do not exist in this phone, and the error mask I am sending you back contains the information of which 2 of the 4 cameras do not exist here. Okay, for the developer to debug the error, the camera module will also print the number of non-existent cameras which Android has requested to turn on, which in this case is 2. So this is what we want to do in this question. Here the camera on request mask is equivalent to our input A and camera bit mask is input B. We want to find the bits which are different between A and B, which would be the error mask, and we want to find the binary distance between A and B, which would be the number of set bits in the error mask. This binary distance is also known as Hamming distance. Okay, if you want to try this question yourself, please pause this video now and start coding. Alright, revisiting the concepts of XOR which we learned in our earlier episode, whose link is in the description. For a given input bit x, x XORed with 1 gives us inverted x. Now XOR both sides with x again. X XOR 1 is equal to x XOR inverted x. We know x XOR x is 0 and 0 XOR 1 will be inverted 0, that is 1. So we have x XORed inverted x equal to 1. Therefore, if the two inputs of XOR are different to each other, then the result of the XOR will be 1. So for our question, we can just do A XOR B and the result will have set bits in the positions where the bits in A and B are different. Considering A equal to 1111 and B equal to 1010, then A XOR B is equal to E equal to 0101. So this gives us our error mask. The set bits here lets us know the positions where the bits in A are not the same as B. Great. Now we can count the number of set bits in E, which would give the total number of bits that are different between A and B. From our previous episode, we already learned the optimized method to count set bits in a number. Please refer to that episode, the link is given in the description below. Alright, to count set bits in E, we do count equal to 0 and then while E count plus plus E equal to E and E minus 1. Finally, the count variable will give our required result, the number of bits in A that are different from those in B at the same positions. Great. From here, I want you to take away a very important insight that will be required in the next two episodes. The result of an XOR between two numbers will have ones only in those positions where only one of the two inputs has a set bit. So, to have a set bit in the XOR result of A and B would be 0 for that bit position, but result of A or B would be 1. That's it. In the next two episodes, we will be solving some tough XOR based problems. Do subscribe to this channel and hit the like button. See you.